This is our first lesson on static electricity in AP Physics 2. If you were in this video, you probably watched the conceptual videos of our lessons that I posted online, and you saw the quantum mechanical model of the atom and that it is different than the one that was presented by Bohr's model. And in this one, in the one that I posted for you to see, you saw the atom's model is where nucleus consists of neutrons and protons, and the electrons are in complex shapes or orbitals, sometimes called electron clouds. And the volume of those clouds can be different, and it's more based on the probability of where the electron is located versus an electron orbiting nucleus like it is in the solar system. So those videos are good to watch. They're not tested on AP Physics 2, but I always include them in our lessons so you understand. So we will be using in static electricity the charge of the proton, the charge of the neutron. Some of the questions will relate even to the mass of the protons, neutrons, or an electron. So I will come back to this information. I'll give it to you. You don't have to memorize the mass of the proton, charge of the proton and neutron, the mass of the neutron, no charge of the neutron, and electron. And so in AP Physics 1, I introduced to you first the Coulomb's law, and you usually tell me that this formula looks very much like the force of gravity because you have a constant. In force of gravity we have the gravitational constant. So in force of gravity we have the force of gravity, the universal gravitational constant, the mass of one object, the mass of the second object, and the distance between them squared. Here we have the Coulomb's constant, which is, I'm going to round to 9, 10 to the 9th. And then we have two charges and the distance between them as well squared. Here you also have to understand that the Coulomb's constant, in AP Physics 1 we didn't have to worry about this part, but here you have to understand that the Coulomb's constant will depend on the electric permittivity constant. So here is the electric permittivity constant, and this constant is the one that gives us 9, 10 to the 9th K, the Coulomb's constant, but it changes. So in vacuum it is 8, 10 to the negative 12, but in different medium it's going to be different. So sometimes you will be given different medium. You don't have to know how to use the epsilon sub-zero, so this one is called the epsilon sub-zero, in your formulas, but you have to understand that it does affect the force between the two charges when they are not in a vacuum, when they are placed in a different medium. So the epsilon sub-zero will change, and so will change K. So K is 9, 10 to the 9th only in the vacuum. Let's look at some simple questions related to Coulomb's law. An object A has a charge of positive 2 micro stands for 10 to the negative 6 coulombs, and object B has a charge of positive 6 microcoulombs. And in AP Physics 1, we did look at what means Coulomb. And we mentioned that 1 coulomb is like a bucket. So when we say 1 dozen, we say that there are 12 in a dozen. The number is 12. But when we say 1 coulomb, we mean there are 6.28 10 to the 18 electrons. So 1 coulomb, it's like a bucket. And inside of that bucket, you have 6.28 10 to the 18 electrons, and it's the same as $1 is equal to 100 cents, or 1 cent is 1/100 of $1. So here you can say one electron is 1.6 10 to the negative 19 coulombs. So if I divide both sides by 6.28 10 to the 18, I'm going to get that one electron is equal to, so one electron is only that part, is only this part of 1 coulomb of the bucket. Coming back to our question, so you have two charges, A and B. One is 2 microcoulombs and the other one is 6 microcoulombs. Because they're both positive, they will repel each other. So if I have one charge which is positive and I have another charge which is positive, the force on the first one from the second one is going to act this way. So I'm going to call this one force on the first one from the second one. And the first on the second one from the first one is going to be acting in opposite direction. So force on the second one from the first one. And from here you see that their magnitudes should be equal to each other, because if this is Q1 and this is Q2, so you have Q2 and you have Q1, then the force between them is equal to the Coulomb's constant, and then you have Q1, Q2, and divide by their distance, so there is some distance, their distance squared. And their forces are the same because it's the same formula for both of them. So the force acting on one is the same as the force acting on two, but the difference is the direction. And the only one that shows the direction but equal magnitudes is B. Here they say that there is an electron and a proton on a hydrogen atom that are separated on an average by a distance of 5.3 10 to the negative 11 meters. Find the magnitudes of electric force and the gravitational force that each particle exerts on each other, and the ratio of electric field to the gravitational force. So if I plug all the numbers for charges and the distance and Coulomb's constant into the electric field force, I will find that my electric field force, or the force of attraction between the electron and proton, is going to be equal to 8.2 10 to the negative 8 newtons. Now to calculate the force of gravity, I'm going to use the force of gravity formula. So if I plug in the gravitational constant, which is 6.7 10 to the negative 11, then I have mass of the proton 1.67 10 to the negative 27, then I have mass of the electron 911 10 to the negative 31st, and then the distance between them squared, which is 5.3 10 to the negative 11, then I get the force of gravity is equal to 3.6 10 to the negative 47 newtons. Now they ask you to find the proportion of the electric field force over the force of gravity. So if I divide 8.2 10 to the negative 8 over 3.6 10 to the negative 47, I will get 2.27 10 to the 39. So this is how much stronger electric field force is compared to the force of gravity between the electron and proton. Here's another question. Find the magnitude of the electric force between two protons separated by 1 femtometer, which is 10 to the negative 15 meters, approximately the distance between two protons in the nucleus of a helium atom. The answer may not appear large, but if not for the strong nuclear force, the two protons would fly apart because they have the repelling force at an initial acceleration of 710 to 28 meters per second squared. To compare this acceleration, the speed of light is 310 to the 8 meters per second. So let's calculate the electric force between two protons. We're going to use the Coulomb's law again. So I get the force of repulsion, or sometimes they call it attraction. The force of attraction or repulsion between two protons is 2.3 10 to the second newtons, or 230 newtons. So here's question 5 from our lessons. 3 positive charges lay on the x-axis. So the charge of the first one given 25 microcoulombs, is at the origin. So they tell you like 0 meters, 2 meters, and 3 meters distances. And then Q2 is 10 microcoulombs, as it is at 2 meter mark. And then Q3 is negative 20 microcoulombs, and it is at 3 meter mark. Find the resultant force on Q3. So Q3 is being pulled by the first one, and is being pulled by the second one. So you have to add these two forces. So I'm going to say force of the first one and force of the second one, because the third one is the negative one. So the force of the first one is going to be equal to, so I have Coulomb's constant 10 to the 9th, and then I have the first charge is 25 microcoulombs. The second one is, or the third one, the last one, negative 20 microcoulombs, but I don't have to plug in the negative. I'm just looking for the magnitude, but the number is going to be negative. And if the force of attraction between two charges is negative, that means they attract. And if the force of attraction between two charges is positive, that means they're the same charge. They will repel. So here, if I calculate what F1 is equal to, F1 on 3. So maybe I'll just write F1 on 3. I can write F1 on 3 here, and F2 on 3 on my graph. So I got 510 to the negative 3 newtons, or 0.5 newtons. And then for the force between the second charge and the third charge is the same formula, Coulomb's law. So it's the second charge, the third charge, and the distance between the second and the third squared. Both of them are squared. So I have 910 to the 9th. Then the charge of the second one is 10 microcoulombs, so 10 to the negative 6. And the other one is still negative 20, 10 to the negative 6. And the distance between the second and the third is 1 meter squared. So I get the force between the second and the third is equal to 1.8, 10 to the, or it's actually 1.8. It's 1800 10 to the negative 3, or 1.8. So I have, that is newtons. And so the resultant force, the sum of those two forces, so the sum of these two forces together, because they're acting in the same direction. So the resultant force, and I can say the summary force acting on Q3 is equal to 2.3 newtons. If I add 0.5 and 1.8, I get 2.3 newtons. I have never seen a question like this on AP exam. Maybe the direction of the electric field force acting on one on the other, but never the mathematical problem solving like this. But I always want to show the students, because you may have this question at the university. So let's solve this question. 3 charges are placed as shown in the diagram. Determine the magnitude and the direction of the net electrostatic force on charge Q1. So here is our Q1 charge, and they give you the distances between them. So your Q1 is positive. That means 3 is acting. So if this is the charge 3, the force from charge 3 on Q1 is going to be repelling. So it's going to be in this direction. And I'm going to call it F3 on 1. And then the second one is negative. And because the third one is positive, so the force on the third one is going to be acting in this direction. So I'm going to call it F2. And the resultant force is going to be, if we create a parallelogram, the addition of two vectors. So your resultant force is going to be in this direction. And what I'm looking is the resultant force acting on Q1 from the other two forces. So at first I'm going to calculate the force between 2 and 3. So the force between 2 and 3 is equal to the Coulomb's constant, 910 to the 9th, then the charge of the second one is 1.2 10 to the negative 5, and the charge of the third one is 4.5 10 to the negative 5. The distance between them is 3 meters squared. So the force of the second one acting on the third one is equal to, or both of them acting on each other with attraction force, equals to 154 newtons. Now, to calculate the force between the third one and the first one, I need to know the length of this hypotenuse in my triangle. So because it's a right triangle and one side and the other side are both 3 meters, then the hypotenuse is going to be the square root of 18. It's going to be a squared plus b squared, which is 9 plus 9, which is 18, the square root of 18. And so the distance here, I'm going to write this distance here is equal to the square root of 18 meters. So if I want to calculate the force of attraction or repulsion between the third one and the first one, again, I have Coulomb's constant, which is 9 10 to the 9. The charge of the third one is 1.8 10 to the negative 5. The charge of the first one is 4.5 10 to the negative 5. And the distance between them is square root of 18 squared. So if I square that, that's just going to be 18. And that will be equal to 0.405 newtons. Now I'm going to redraw my triangle, and I'm going to look how to find the resultant. So here I have this force, which is 0.54. Then I have this force, which is 0.405, and my resultant force from the parallelogram is going to be this one, F. And I can use one of these triangles to find the resultant. Because it is a parallelogram, the length of this vector, or this side of the triangle, is the same as the one that we found, force F3. So I have one side is given, I have another side is given, and if I can find one of the angles, I can use the law of sine or cosine to solve this triangle for the resultant vector F. If I look at my original problem here, the diagram, I have, let me do a different color. I have the hypotenuse, and then I have this vector, and they are parallel to each other. And then I have this part right here, cutting both of them. So this angle is going to be equal to this angle, and they're called alternate interior angles. So if I use my original triangle to find this angle, let me call this angle theta. So this angle is going to be called theta. That is, this angle is also theta. So I'm going to say that the tangent of theta is equal to 3/3. And because it is both sides of this triangle equal to each other, you know that's 45 degrees. So theta is equal to the arctangent. In your calculators, it looks like this, of 1, which is 45 degrees. So coming back over here where we started to do the law of sine and cosine, so I know this angle is theta. So what I have is side, angle, side. When I have side, angle, side, I use the law of cosine. So with that, if I'm looking for the resultant vector, which is F squared, that one is equal to one side squared, which is 0.5 squared, plus the other side squared, which is 0.405 squared, minus 2 times their product, which is 0.5 and 0.405, and then cosine of 45 degrees, the angle between those two. So I get the force, the resultant force is equal to 0.38 newtons. Again, I haven't seen anything like this complicated on AP Physics 2 exam. Maybe AP Physics C calculus-based problem, you will see something similar, but not on AP Physics 2. But I want you to see this question, and also I want you to know that when they give something similar, not this complicated with calculations, but when they give you something similar on AP exam, they will be looking most likely the direction of the resultant force. So you have to be able to show that, let me maybe erase this to make it a little bit clearer. So you have to be able to show that there is the force of attraction, there is the force of repulsion, and if you make a parallelogram, then there is going to be the resultant force. So that's all I have seen on AP exam for AP Physics 2 or AP Physics B when they look the direction of the resultant force. So if I haven't seen the previous question on AP exam, but I have seen this question on AP exam similar to this one. 2 pith balls shown have mass of 1 gram each and have equal charges. One pith ball is suspended by a thread, and the other charge is brought to the second one within 3 centimeters of the suspended ball. The suspended pith ball is deflected from its rest position until the thread forms an angle of 30 degrees with the vertical. At this angle, the ball is in equilibrium. So calculate the gravitational forces, calculate between them, calculate the electric field forces, and calculate the charge of the pith balls. So the force of gravity acting on the pith balls, so for both of them, the force of gravity is mg. And because the mass is 1 gram times 10, so the force of gravity is going to be equal to the mass, kilograms, times 10, and it equals to 0.01 newtons. If I have to calculate the force of attraction between them, again, it's the force, gravitational force or attraction between them two. I have the gravitational constant, the mass of the first one, which is 1 gram, times the mass of the second one, which is the same, 1 gram, and divide by the distance between them squared, which is 3 centimeters, centi stands to -2 squared. Then I get 0.74 10 to the -13 newtons. If I'm calculating the force of electric field between them, I will need to draw the forces acting on the pith ball. So I'm going to draw this one. This one has the force of gravity, which is mg. We just calculated that one. And 0.01 newton. And then we have the tension force acting on this ball. And because they're the same charge, then they have the repulsion force, which is electric field force. And if I draw the components of the tension force, so here's the tension force, then I will have, this is my vertical component, and because it's equilibrium, the vertical component of the tension cancels the force of gravity, and this is my the horizontal component, and here is an angle of 30 degrees. So I can say this is tension cosine of 30 degrees, and this part is tension sine of 30 degrees. I'm going to call it theta, and to make them equal, I'm going to make it a little bit shorter so they look the same, so they cancel each other. So the electric field force in this case is equal to T sine theta, and T cosine theta is equal to mg. So from here I can find what T is equal to. So the vertical forces, I'm doing the net force is equal to ma. So what I did is F net is equal to ma. There is no acceleration, so T cosine minus mg is equal to 0, and electric field force minus T sine is equal to 0, and I got the system of two equations. So from here I can find that tension is equal to mg divided by cosine theta, which is 30 degrees. So I have 0.01 divided by cosine of 30 degrees, and that will give me 0.0115 newtons. Now I'm gonna plug it into my electric field force to calculate the electric field that they asked me in B. So electric field force is equal to the tension force, which is 0.0115, and then I have sine of 30 degrees, and sine of 30 degrees is 1/2, and all this is equal to 0.00576 newtons. And because the electric field force is equal to K, and in our case the charges are the same, so it's Q times Q, which is Q squared divided by the distance squared, I have the force, electric field force is 0.00576 is equal to K, which is 9/10 to the 9th. Then I have the charge squared, and distance between them is 3 centimeters, 3/10 to the -2 meters squared. So from here I find that the charge is equal to 2.4 10 to the -8 coulombs. So this was the introduction to Coulomb's law, and it's a little bit more complicated than it used to be in AP Physics 1. Not too much, but it had one of the laws of cosine and sine that sometimes you have to use to solve these questions, and 3 charges where it gets a little bit more complicated, but not that much. So next video is going to be on, and the link is going to be in the description of this video. The next video is going to be about the electric fields and equipotential lines. And I have seen a few questions on AP exam that involve the concept of equipotential lines and electric field lines. So thank you for watching this video. Follow the links in the description, and I will see you in the next video.